So in this video we're going to talk about whether something is invertible and finding an inverse function. So if a function is one-to-one, now if you haven't seen the previous video you need to go look at that before continuing, but we talked about one-to-one functions in that video. If a function is one-to-one, then it has an inverse function, meaning that its inverse, found by switching the coordinates x and y, is also a function. If we have that kind of situation, the inverse of a one-to-one function, then we call that function invertible. Okay? It's invertible because it has an inverse, meaning its inverse is a function. Now, let's take a look at what, it's kind of a mouthful, let's take a look at what we were just saying. This function here, does it have an inverse? Well, if it's one-to-one, is it invertible? Okay? If it's one-to-one, then it has an inverse and it's invertible. So let's take a look. If I look at the x value, the x coordinate here is -1 and the y coordinate is 4, then I also have an x coordinate of 1 and a y coordinate of 4. In other words, I have this situation. Alright, which means that this thing is not one-to-one, and if it's not one-to-one, then we know that it's not invertible, meaning its inverse is not a function. It's not invertible. Okay? Now, before we get too much further, I do want to explain some notation that with which you need to be familiar. If the inverse of a one-to-one function is this function. So let me go ahead and say this. So if I have the function f and I have its inverse, the inverse of function f is written this way. It's f inverse. Now, that's not f to the -1, it's f inverse. Okay, so it just means we've already taken the inverse, and the inverse is indeed a function. So let's take a look at this g function. I'm looking to see if any two pairs of coordinates have a different first coordinate with the same second coordinate, and they don't. So first of all, we know it's a function. Secondly, it doesn't have a closed beak either, so this is this is indeed one-to-one. Well, if it is one-to-one, then it is invertible, and that's what they're wanting to know. Yes, it's invertible. Okay, now it does say to then find the inverse. Well, we find the inverse by just merely switching the x and the y values. So I'm going to say 2, 3 is the inverse for that particular coordinate point. Now let me go ahead and write my function notation for the inverse. G inverse is written that way. That's G inverse. So now let's go ahead and write the rest of our inverse. And you remember that from Algebra 2 that that to get an inverse, all we need to do is switch the x and the y. Alright, so there's the inverse of g. F didn't have an inverse because it was not one-to-one. Alright, thanks a lot for watching.